Okay, so we have now a basic principle, which is if the cross-section of a solid is constant, then the volume of that solid is the area of the base times the height. And that tells us how many volume units we can contain. In the case of the example we had here, how many 1 centimeter cubes or how many cubic centimeters we have of volume. Now, let's apply this to a cylinder. Okay, we have a cylinder. We have a cylinder here. And we can take a meter stick and measure it, and we've done that. We see that the diameter is about 12 centimeters and the altitude is about 16 centimeters. So how do we find the volume of this cylinder? You should work that out before you read or listen to anything else. Okay, well, we have this principle. Volume is the area of the base times the height. We want to find the volume. We're given the height. We need to find the area of the base. Well, what's the base? The base has the shape of a circle, and any cross-section has the shape of a circle. Now let's digress for a second and talk about what we mean by a cross-section. A cross-section is any, okay, if let's say this is a solid cylinder, we've got the altitude, which is 16 centimeters. A cross-section is any slice we want to make in this thing perpendicular to the altitude. So any way we slice this thing in a horizontal plane, which is of course what's perpendicular to the vertical measure of altitude, is going to give us a circle. And it should also be clear that the same is true for, let's say, this solid. No matter how we slice it, if we take the altitude to be 10 centimeters, no matter how we slice it, we're going to get a 4 centimeter by 10 centimeter rectangle. So that's what we mean by cross-section being constant. For the cylinder, that's certainly the case, so this applies. Now, again, we're given the height. We want to find the area of the base, which is also the area of any cross-section. Well, the base is a circle. Any cross-section is clearly going to be a circle. So the question then is, how can we use the information we have to find the area of that circle? Well, we're given the diameter of the base. The base is a circle with diameter 12 centimeters, so we can easily find the area of that circle. So we have the base diameter, which is going to allow us to find the area of the circle. We have the height, which we can then multiply by the area of that circle, giving us the volume, area of the base times height. So what's the area of the base? Well, the base is a circle. How do you find the area of a circle? Well, people had a little trouble answering this question because a lot of people don't remember the formula for the area of a circle. But more fundamentally than just remembering a formula, remember that in our preceding class before last, we reconstructed a circle into an approximate rectangle by, you recall, slicing it. Well, that's not a very good way to slice it. We sliced it up into a bunch of, I'm messing up the slicing, but you understand the idea. We sliced it up into a bunch of wedges, which we then stacked to make an approximate rectangle, whose dimensions were approximately equal to the radius this way and half the circumference this way. The circumference being pi times the diameter, it's 2 pi times the radius. So when we finished this construction, we had something very close to a rectangle that had dimensions radius here and half the circumference, which is pi times the radius here. And when we multiply the radius by pi times the radius, we get pi r squared. Now, you don't have to remember that derivation, that whole idea, but you should understand that there's a reason for this formula. It just wasn't handed down on a stone tablet, and the reason, in fact, is not beyond your comprehension. I might well give an extra credit problem on a test that asks you to reproduce this. I wouldn't require you to understand this simply because the text doesn't go that deep and the course is not really designed to go quite that deep into the reasoning behind some of these things. Still, my main point today is that there are reasons and these things can be reasoned out. So, now that we either remember the formula pi r squared or reproduce it by slicing up a circle, we know that the area of the base is pi r squared. R is, of course, half the diameter, and the diameter was given to be 16 centimeters, so the radius is 6 centimeters. And it follows that the area of the base is pi times the square of the radius. Square of 6 centimeters is 36 centimeters squared, and that's multiplied by pi. Now, I didn't multiply by 3.14 or 3.1416 or 3.14596, 3.1415926, and I didn't multiply by 22/7, any of the approximations of pi. I simply wrote 36 pi square centimeters. Now, that being said, we weren't able to measure the diameter all that accurately, and we probably don't need many significant figures of pi to give us a good approximation to the area of the base. But if I'm going to write an equal sign, I'm going to have to use pi here. So what I say then is the volume is the area of the base times the height, which is 36 pi square centimeters, area of the base, times the 16 centimeter height. Unless I screwed up my multiplication, 16 times 36 is 576. You can check me on that. I'm committed. Okay. And I make mistakes, so if I made one, you get to find it and tell me about it. Okay, so we have 576 pi cubic centimeters. Pi is a little over 3. 576 is a little under 600. 3 times 600 is 1,800. So we have approximately 1,800 cubic centimeters. And given the lack of great precision in my measurements, that's probably close enough. But you can multiply this out to any number of significant figures. You're probably not going to get much closer, though, to the actual volume than this. Again, because of the imprecision of the measuring and some of the rounding I did. Main point here is that we deconstruct this volume equals area of base times height. We know we have the height. We have to find the area of the base. We identify that the base is a circle with a diameter of 12 centimeters. We find the area of that circle, then we construct the area of the, we get the area of the base, the area of the circle, and we multiply that by the height to get the volume. We break what is a problem we don't know how to solve down into individual steps, and we end up with a solution instead of just quoting a formula for the area of a cylinder.